Hello, and welcome to another hugely important NestGen 24 session. I am Rohan, currently working as a Customer Success Associate here at FlightBase, and I'm delighted to welcome you all to this session. How are you finding the session so far? Please let us know in the chat section and do share your feedback at the NestGen wall of tab. It will definitely help us curate the sessions better in the upcoming edition. As a dependency on renewable energy sources are growing, the need for efficient inspections of, say, wind turbines, solar farms, and other assets become critical for mankind. To shed some light on such crucial use case, at this session, we are going to deep dive into elevating wind turbine inspections with automatic drones and AI-based defect detection. To go into greater detail, we have a very special guest among us. So let's welcome Paul Fontaine, founder and CEO of SkyVisor. SkyVisor is a drone-based autonomous industrial inspection software suite company based out of France that empowers wind and solar farm operators to optimize their operations and maintenance by in-housing their inspections. It features automatic data acquisition and AI-based processing to maximize asset performances while reducing downtime. Paul's background is in electrical engineering and computer science with a particular focus on drone design, cloud development, and big data management. Before founding SkyVisor, Paul had been designing and deploying industry-focused drones for over 8 years, leading to the creation of SkyVisor, which is currently operating in a total of 17 countries worldwide. So before I let Paul start sharing his insights, I would like to share a few housekeeping rules. So please type in your questions in the Q&A tab of the session, and it will be answered at the end of the presentation. The session is getting recorded and will be published soon. We also have a SkyVisor booth in the Expo section, so please make sure you do visit it during the networking and booth visit slots. There's also an online poll during the session, so please do participate. Finally, please do remember to capture your favorite moments of the session and share it over LinkedIn or other social media handles by using hashtag #NestGen. Few lucky people who share might also have a surprise in store. Last but not the least, I would like to extend my gratitude to our title sponsor DJI Enterprise and Sunflower Labs, which is also our gold sponsor, for their invaluable support throughout our journey. And with that, over to you, Paul.
So thank you for this intro. Thanks. Hi, everyone. I'm Paul. So I'm the founder and CEO of SkyVisor. As one mentioned, we are a software company focusing on renewables inspections. And today's sessions, we're going to try to focus onto the wind turbine inspections and how the data can be collected, can be better collected using autonomous drones. And then what are the different challenges regarding defect detections, data processing, and how AI can actually works. I'll try to make this session as insightful as possible. I know you guys might not be always familiar with what are the different renewables type of inspections, and especially for wind ones, and we'll try to share as much knowledge as we can today with you. So please, if you have any questions, we'll be very happy to answer them straight after the session into the Q&A, or have a look at our booth, virtual booth onto the event. All right, so just a quick intro regarding the company. So we do our software specialized companies, and we're specializing only onto 3 different products. I would say the first one is the wind turbine inspections. It's going to be the focus of today's session. But we do also have 2 other solutions that are dedicated for solar plants inspections. One of them featuring thermal inspections capabilities, and the other one doing construction monitoring for PV plants. What we do as SkyVisor is software. Once again, we are specializing into the collection, but also the processing. And I'll try to give you a quick insight, of course, of what our products looks like, but I'll rather as well share some knowledge about the industry itself. We've got some experience, 6 gigawatts of wind and solar assets inspected worldwide, and the company has been operating for the 6 last years. And it will be our pleasure to share all those insights we got from those years of experience. Basically, solutions, as you may already see on the right-hand side, is features and divided into 2 parts, one of them being automatic drone flights, which are compatible with DJI drones and DJI dogs. And the second one is data processing, data management, which is definitely focused for the end users, which in our case today are renewables operators. So gonna jump right into it. This is a bit of track record we do have in the 17 markets, as Rohan may have mentioned just before, and a couple of logos that you guys may know. Those are always operators and energy operators operating either wind turbines or other PV plants. So just maybe have a quick look at the renewables market. On the right-hand side, just here, you can see two insightful maps, one of them featuring the wind turbines being installed worldwide and the utility scale photovoltaic plants as well. So as of today, 2024, we are actually having 450,000 turbines installed worldwide. That's quite a big amount and quite a big growth over the last years. And in terms of PV plants, we've been reaching the terawatts of installations, which is, just to give you a quick comparison, the size of Tunisia. So imagine Tunisia being entirely filled with solar panels. The context, as you may also have seen onto the news, is very favorable. A lot of turbines are being installed more and more. And right now we are on a key phase in 2024 because 32,000 turbines will be actually age of 20 years and more in 2028. So which means there is a bunch of turbines to inspect. There is more and more wear and tear over those turbines. And when you have a quick understanding and quick look at a normal renewables life cycle, you have to understand that the part operation maintenance, which is actually when the turbines or the PV plant is actually running, it lasts for 25 years in average. So there is more and more maintenance, more and more inspection to be led over the years. And having in mind that all those turbines are quite old, there is quite a big challenge regarding the number of inspections that should be carried out. And it's exactly where drones take into place. Second very interesting factor is the drop of energy guaranteed price. I don't know if you guys know, but in order to start this business, start the renewable business, a lot of governments have been actually subventioning and helping those industries to start and grow. But now that it's becoming more and more mature, the price, the guaranteed price is dropping to make it more, I would say, comparable to coal price industry price simply. And so this forces basically our clients, which are the operators, to focus more and more onto the operation and maintenance side. So just to give you a quick overview, there's a ton of components in wind turbines and PV plants, and the one we're going to focus on today are the blades. As you may know, wind turbines are composed of 3 blades, and those blades should be inspected once to twice a year, depending on different markets and different, of course, wear and tear. And because a successful drone-in-a-box deployment always comes with a successful as well business plan, it's interesting to know that a blade inspection today is priced around $700 as well. So quick question for you guys, just before kicking on this session, is what do you think is the daily production loss when a turbine is actually done, when we stop a turbine based on a 4.2 megawatt turbine? So there is the Q&A on the chat, and you may answer either $200 per day, a loss of $1,000 per day, $1,200 per day, or $2,000 per day. I'm going to give you a couple of seconds to get some answers.
Yeah, Paul, just a minute. The Q&A hasn't started. Just a second. I will turn on the poll. So guys, you will be having 30 seconds before you answer the polls. So yes. So yes. So the poll has started. So you can answer it by navigating to the polls tab. When you navigate to the session tab, there you can see 3 toggles between chat, polls, and Q&A. So you need to go to the poll section, wherein you can see this question down there. So you all have 30 seconds to answer, and I will be closing down this poll afterwards. So 0% people say like $200 per day. 5.3% said $1,000 per day. 52% of them said $1,200 per day, and 40% said $2,000 per day. So the maximum of the votes have gone for option number 3, that is option C, $1,200.
Okay, let's see together what the answer is. Indeed. Answer C is the correct answer. Congratulations to the ones with the good one. It's definitely a large amount of money that you lose whenever a wind turbine is actually being stopped, and it's exactly where the kind of solutions provided by drones is very relevant, because as you may have seen, number of inspections we should do, we cannot afford getting the turbines down. The turbine can be down for inspection purpose, but if the inspections has been poorly carried out, there might be as well some corrective maintenance happening there because of a blade failure that leads to actually a very important defects afterwards. So when it comes to blades defects, I wanted to share with you guys a couple of insights regarding how blades are made actually, and what are the main defects you can find on it. So blade is usually made of composite material. Most common one is being fiberglass reinforced epoxy. And as you may have seen on the right-hand side, there is a bunch of different measures and metrics that can be found out of blades. Here you have a cut section of a blade. You see it looks very similar to actually a plain wing, and it's basically doing the same job, except that instead of course, lifting a plane, it's actually rotating. So there's a couple of technical keywords to understand, very importantly. One being, of course, the size, the different size you can find onto a blade. So on this section, you can find what we call the leading edge, which is the edge that faces the wind first in a certain way. And then on the other side, you do have the trailing edge. A composite blade is usually composed of 2 different sections, and one of them, and both of them being glued onto those different edges, as you can see here in the dark areas. So this is definitely a key point to actually understand and to inspect, because if the wear or tear is too important into this section, then it can lead to a shell separations basically, and the blade can open itself, as you may see right here. You can see perfectly 2 different shells being open into what we call the leading edge erosion. So basically a blade has 4 actually very common defects. One of them being the erosion of the leading edge. So once again, is this area that gets eroded. One of them is the erosion of the leading edge tape, which is actually a protection you can put onto the leading edge to reduce this wear and tear of the leading edge, but that actually gets used over time as well. So you need to change it, and change it before it actually gets transformed into a leading edge erosion issue, and even worse, into an opening shelf issue. Third defects that are quite common on blades is you have a bunch of different add-ons, what we call, which are additional components that you can put onto blades to make sure the airflow is actually as smooth as possible. And those missing add-ons can actually be damaged as well and create noise, or worse, create vibrations for the blade, on the blade. And then last but not least, one of the very common defects is what we call the lightning strikes defects. So as you may know, wind turbines are very tall structures. Blades can measure up to 131 meters when it comes to offshore turbines. And of course, when a lightning strikes occurs, it's very likely going to go through the blade. So of course, blades are equipped with a specific system that can fail sometimes to time, and the strike can actually strike onto the composite part of the blade. So those are the very common defects. Of course, there is very common inspection methods. Turbines, as you may have seen, they have been over on the market for the last 20 years, and inspections are already being carried out. One of the very common inspection method is human contact inspections, which are basically rope access technicians, inspectors getting down onto the blades to making sure they're doing a visual inspections of blades. Second type of inspections you can find on the market, those are camera-based inspections. So basically technicians from the ground with a very large objective, very high quality camera trying to collect a very good data, which is quite hard because you do have to change the rotor angle quite often. And then the last but not least one is the drone-based inspection ones. That one we're going to focus on today, of course, with this event. That is very interesting. Just a quick overview. I think it's quite impressive. One of our customers actually that does as well rope inspections, and you can see how dangerous it can be when you actually get down onto a blade. Basically, to carry out these inspections, you need, as you may see, the rotor to be locked into a very specific position with one blade facing down. And then the inspector can go up into the top of the tower with the help of an elevator, most of the times, hopefully for him. And then he gets down on ropes and then has to switch in between every single side of the blade to make sure he has a very good coverage and a good inspection. So as you may see, it's quite dangerous, quite long as well to carry out. You have to imagine that such inspections are actually taking about 4 hours to inspect the 3 blades of one turbine, when drone inspections are way faster. So drones, because definitely topic of today's meeting, today's conference. You guys are very familiar with drones. I'm sure you know how beneficial it can be and how efficient they can be on site. Well, here I wanted to maybe emphasize on 3 different points. One is, of course, the speed of drone inspections compared to the other traditional methods. How cost-effective it can be when you understand the downtime and the power loss that leads to turbine downtime. Then you understand that having a fast inspection is very important, and it's a key point to face the upcoming market. And then the last but not least benefits is definitely the quality of data you can achieve with such drones. There's been large improvements into drone quality and drone camera quality over the last years. But those drones, I mean, we're still very much into the manual inspections, and manual inspections is facing actually a lot of limits when it comes to inspecting a large 3-dimensional structure like wind turbines. One of them is actually having a very close and precise flight. Usually, when you want to gather very high definition pictures, you need to be very close to blades. And when we're talking about very close, we're talking about 4 meters away from a blade. And I'm sure no drone pilots wants to bring a $20,000 drones 4 meters away from a blade. Mostly when it comes to getting underneath blades as well, there is a very strong perspective point of view when you reach 200 meters of height. And so it's quite risky. It's where automation really adds up a lot of value. The other point is definitely uniformity of pictures. I just showed you a quick example down there. You see the 3 pictures, they look very similar, but in fact, those are 3 different areas of the blade. Indeed, blades are large, wide structures, and it's very hard to actually localize yourself onto a blade, and it's very hard for manual pilots to actually make sure there is a uniform data collection. So it's something quite important as well to take into consideration if you want to do a fast and effective inspection. And last but not least, it's the limited knowledge of about blade defects. As you may have seen in the previous slides, blades is quite challenging and difficult component to inspect. You have to understand all the techniques that is beyond blade constructions, including composite material knowledge. And it's something that companies like SkyVisor is bringing as well on the market. So quick question for you guys again. How much time do you think it takes to inspect one full turbine using an automated drone? Okay, not a manual one, but an automated drone using a solution like SkyVisor. 4 possible answers. First one is 80 minutes, second 25 minutes, third one 30 minutes, and last one 37 minutes.
So guys who are joining in now, the questions are published in the poll section. So you can navigate to the sessions tab and can go to the poll section wherein you can answer your questions. So we'll be having 1 minute. So yeah, go for it. 9 votes have gone for 18 minutes. Again, 9 have been given to 25 minutes, 4 votes for 30 minutes, and 2 votes for 37 minutes. So A and B, they both have got the same vote percentage.
Okay. So the correct answer is actually 18 minutes. All right. Indeed. Solutions, automated solutions like the one brought by SkyVisor on the market, enables very fast inspections and with total uniform data acquisition, which is very, very important on the market. When it comes to modern data collection, I just wanted to have a quick word and a quick clarification on it. Of course, you guys know about digital twins. It's a quite trendy word, and digital twin is actually a digital representation of a component or an asset. In this case, those are wind turbines and especially composite blades that are being digitalized thanks to the SkyVisor solution. And when it comes to digital twin, something that is key is to get, I would say, continuous data flow of inspections, because a lot of times you do have very high quality inspections, but if you do them only every 5 years or every 10 years, it doesn't make much sense when the defects can basically appear the day after your inspection. So that's why as SkyVisor, we're really focusing on to deploying drone at scale and make sure this data acquisition is as cheap as possible. And it needs to be very well organized and ordered. So that's why we've divided into 4 different steps. One of them, first one being planning, of course, of inspection. Second one being the data acquisition. Third one being analysis of those data. And last but not least, and something drone specialists should not forget, is that once this data has been acquired and processed, it should lead to an industry-specific decision-making, all right? And it's actually where it comes to maybe leading to a new maintenance strategy or maintenance campaign, or simply the end customer can decide not to inspect and go back to an inspection a bit later on. That can be led maybe 6 months after to actually closely monitor the defect propagation. So a quick overlook of the solution and how it's divided. It's actually divided into 2 parts. One of them is really focusing onto the acquisition, making sure we have uniform data, using DJI compatible drones, dogs as well. And the other part is being a web platform where actually you can gather all those data, process them, and then collaborate and take decision. Those 2 softwares are really focused for wind turbines and PV plants operators. Quick overlook maybe of the mobile app, just so that you guys maybe project yourself into a daily usage of such solution. We're talking about dedicated app that you install directly onto the drone controller, or you can as well install onto DJI dog using flight-based interface as well. And then it leads to a custom 3D flight. We're talking about 4 meters flight. We have 1 picture that is taken every 2 meters, and the 4 sides of the blades are covered. So it's very, very important to get always the same type of data acquisition, because we're going to see just after how important it is to monitor defect propagation. Of course, data quality is key. And something that is quite important is once you're on site, you can actually do also live defect annotations, which means if you see anything on the blade, if you see any defects, instead of sending back the data, waiting for the process, and then getting back on site to conduct the repairs, you can actually on site already label a couple of pictures and mention that there is a strong interest into checking those pictures quite fast after the inspection, because they might lead to an important defect. And in the worst case, we're gonna stop the turbine straight after the inspection. All right. Something quite important to the data collection is that data is correctly ordered. Blades have turbines have 3 blades, and it's important to make sure you know on which of those blades the defect is. So usually they are named A, B, C. It's important as well to know on which side the defect is. So we've been seeing together the leading edge, the trailing edge, and the 2 other sides, they are the suction side and the pressure side. After that, if you want to send any maintenance team onto the blades, they need to know how far it is from what we call the blade root distance, so from the blade base, and how far is the defect located, which is something we measure with SkyVisor. And then to actually conduct a good defect propagation monitoring, it's key to know the defect size in centimeters, most of the cases. All right, so here's a couple of shots of very nice defects taken by our solution. On the left-hand side, you can, of course, recognize an onshore turbine. There we are about 200 meters height, and the drone is 4 meters away from the blade. And there you can see some leading-edge erosions. Already you can see the layers underneath what we call the gel coat, all right? And you can see some fibers, which is a bit more brownish. On the right-hand side there, we see an offshore wind turbine, and then you can recognize leading edge erosion. There might be a first layer protection, like leading edge tape, that you can see is actually getting out. Once you've collected all those data, the question is, how are you going to process them? Because you have now cheap inspections. Maybe it's going to lead to more frequent inspection as well, thanks to docs, thanks to in-housing as well. And then you end up with more than 360 pictures per blade inspection. So it can represent quite a lot of data to process, quite some high definition data as well. Just to give you an idea, but the GSD, so grain sampling density, is actually a 5 millimeter per pixel. Okay, so those are very, very large data and pictures. And so the challenge is first how to organize them. As we may have seen, nothing is more similar to a blade picture than another blade picture, maybe a couple of meters away. So that's important to really wisely organize them, wisely look at them as well to make sure you can find the correct defect, and you need a bit of knowledge for that. So it takes time and expertise. And then once again, we talked about how important it was to see how fast a defect will propagate. And there you see a good example of 6 different inspections on the same. And thanks to SkyVisor solutions, all those inspections have been done the same way, the exact same way, even though it was different pilots, different hardware. And then you can wisely monitor this kind of crack, okay, which is a spoiler-induced crack. So where comes, of course, the second piece, very important, data processing platform. On our side, SkyVisor is providing a SaaS software as a service solution, which is available worldwide, of course, that does input a lot of different data. So, of course, we've been talking about blades so far. You can also input some tower inspection, some internal inspections as well. So here you have some screenshots of the platform. You can see some inspections taken from the inside part of the blade, some pictures taken from the outside as well. And when it comes to doing a maintenance on site, it's quite important to get a tablet or a phone access. Once you're on those ropes, you don't want to carry a computer. So that's why we do have as well a mobile phone versions of that. What we bring the industry on this side is definitely some best practices in terms of data organization, in terms of defect labeling uniformity. And then you have very strong and powerful PDF export options onto the platform. And you can, of course, as well, check the propagation of those defects. Something important as well on this platform, and something quite trendy, of course, over the last years, it's the so-called artificial intelligence defect detections. I just wanted to take the occasion of this show to maybe precise a little bit about AI, the AI word. Maybe some of you know, but it's important to understand that machine learning is actually part of the AI universe. And then the next step is deep learning, which is neural networks training. And it's what we are using here at SkyVisor, which is a very specific part of artificial intelligence. Models, we're actually customizing them to clients' requirements, depending on clients' data quality, clients' defect labels. And there you have a very high-level defect pipeline. When we start with the raw blade picture. There's quite a lot of challenges around this picture. It's high definition. It has very different backgrounds, which can be the sky, which can be land, which can be fog sometimes. So there's a first big challenge, which is to isolate the component that we want to inspect, which is the blade in this case, and then to make sure that we find correct defects onto these blades. So this is a pipeline that is, of course, within our solutions. We're going to disclose much more information, as you may understand, but it's definitely something important. It helps usually our customers to reduce by 60% the time they spend onto blade analysis. I'm arriving almost to the end. Just here a couple of shots of automatic defect detections of very, very small and small defects. You can't even see here on the picture. And yes, I think what's best than actually getting a quote from one of our clients, Jose, which is one of our pilots overseas, has been actually testifying about our solutions and that we actually meet the requirements. And also we do have a maintenance manager.
Messinguet, donc je suis responsable de la maintenance dans la société Zephyr ONR. Donc Zephyr est un bureau de développement qui développe des parcs éoliens. Donc on est basé principalement dans le quart nord-ouest de la France. Du coup, c'est prometteur parce que ça répond à un besoin du coup qui est de mapper la pale dans son intégralité. Dans le cas d'un défaut, par exemple, si on loupe un défaut de visu et s'il arrive un litige avec l'assurance, l'assureur va nous demander, pour prendre en compte ce défaut comme un accident et non comme une usure, de prouver que ce défaut est apparu soudainement. Pour des entreprises qui ont beaucoup d'inspections de pales, beaucoup de parcs, ça peut être très intéressant parce que en une journée, on peut réussir à gagner un nombre d'inspections vraiment conséquent.
So it's definitely, of course, Maxim's testifying of the use of the company, of the software. And just, I see the time's running. We are a little bit out of timing. Just to have a very fast conclusion altogether. Key takeaways regarding blade inspections is definitely the usage of drone is growing. You may have noticed it into the different locations you guys working from. There's some key challenges regarding data collection as well as data processing. And I believe it's a great opportunity for all the drone actors to actually focus onto this market. And of course, we're here for you to help you on getting this industry best practices to work for both wind turbine inspections as well as thermal inspections, but also PV plants construction monitoring using different type of hardware. And there is a bright future for all those drone inspections. I would say mostly onto large farms where drone-in-a-box technology can be definitely useful, and mostly for offshore inspections as well. You do have usually 50, 60 turbines on the same location, and then you don't want to bring a technician or a pilot offshore. It can be some very challenging conditions. So there is a huge amount of work to do on this direction, and I am sure you guys can actually help onto deploying such solution. Thank you very much for listening, and hope to talk to you soon. And don't hesitate to visit our booth. And now I think, Rowan, we do have a Q&A session right now, no?
Yes, absolutely. Thank you so much, Paul, for sharing your insights. It's quite interesting to see how the technology has progressed so far, and with better reliable hardware as well as optimized software coming in, just the future is not very far. I'm sure it will definitely benefit the audience looking forward for an autonomous inspection software for wind turbine inspection. And now we would like to open the house for a round of Q&A. So I guess we have received few Q&A questions, and I will quickly check that. If not, people who are joined in, you can put out your questions on the Q&A tab. And yeah. So Paul, we have 4 to 5 different questions. So I will just read out those for you. So one was that, how do you tackle the issue of insurance coverage for such missions, given the assets being inspected are very expensive? So it would be great if you can throw some light on that.
Yes, definitely. It's a big challenge for any inspection technology, drones, contact inspections like rope access. Today, insurance are used to drone inspections, and they are as well very aware of the limits as well of such inspections, being drones or being rope access, because here we are talking about the same category of inspections, which are visual inspections, visual remote inspections. And so it's part of the inspection procedure. It can be complemented with all the type of inspections, as we mentioned, inside that inspection. That's why it's key to us to actually embed all those data into this very same platform. So this is how the issue is taken into the industry. Insurance are present on one side, but they are not as strong as in other industries neither, and operators are very aware of this.
Absolutely. Thank you so much for answering that. We have one more question that states, say I'm using some other software for flight operations since I'm accustomed to its UI. However, I would like to use SkyVisor software for post-processing. So is it possible to export the mission planned in SkyVisor to the software that I'm already using?
Yes, definitely. So software is a generic platform to gather all type of data. So we've been talking a lot about drone data, but we can actually input internal data, rover data, rope access data into it. So it can be other drone providers' data as well. We do have we do support a couple of providers already into the import system. Something that is worth mentioning is that we've been developing a dedicated mobile application because data quality is key into this procedure. And so it's important that your data is actually meeting our requirements regarding metadata provision as well as GSD requirements. So it's definitely something we can talk about and see a bit the data set you guys have. So if you just want to contact us right after the session, we'll be pleasure discussing about that.
Definitely. So one more question was that what is the exact percentage of the average return on investment that you have observed across this industry?
Yeah, so basically the wind turbine and rotor blades defects are actually leading in average to a 4% annual power loss. It's something that has been demonstrated by a couple of studies. And so here, when it comes to SkyVisor and drone frequent inspections, more generically, you can't realize how much operators and turbines owners don't know about blades. For them, it's 3 big black boxes rotating and producing energy, and they are not aware of all the defects. So one very important part and challenge that those kind of inspections is meeting is actually to bring back the knowledge to the operators so they can challenge people we call the manufacturers. Manufacturers are the wind turbines original equipment manufacturers, basically, and they have a total control over those assets. So it's important for them, for operators, which are the end clients, to understand what is the real health status of those turbines, afterwards to challenge those contracts, and then they can see up to 4% of benefits.
Okay, thank you so much, Paul, for answering all the questions. And would you like to share any more would you like to share any closing thoughts?
No, well, I'm very well. Thank you of course, for the invitation. Looking forward on deploying drone at scale using autonomous drone boxes.
Absolutely.
And with pleasure, yes, you guys having us at our virtual booth right now to actually have a deeper look at your use case and see how this kind of technology can help you deploy drone at scale into your respective businesses, either wind or either photovoltaics.
Thank you so much for that. So thank you everyone for joining in from different parts of the globe and taking out your precious time, and hope you are having a great time at NestGen. Let us know how you find out the session in the comments